Hi, so we need to find the area between the parabola. We have parabola 1, which is x squared is equal to xy, and we have the second parabola, which is x squared is equal to 16y minus 16. Okay, so first thing that we need to do is to graph and sketch these parabolas in order for us to to show which area are we going to find. So first, let's try to find the vertex of these two parabola here. So we have x squared is equal to 8y, but remember once again that the vertex form of our parabola, we have y is equal to a x minus some constant h squared plus k. Okay, so we need to transform this into this one. So we have y is equal to x squared all over 8 or 1/8 x squared. Okay, so as you can see here, our vertex is equal to our h here is 0, and our k here is also 0. So our vertex here is 0 at point, at the coordinate 0, 0. So v is equal to hk. Okay, so while on the other hand, our vertex on this parabola, let me box this important notes. So we have x squared is equal to 16y minus 16, and in order for us to separate our y, so let's try to have here 16 y minus 1 x squared, right? Then y minus 1 is equal to x squared all over 16. Then our y is just equal to, placing this negative 1 on the other side, we have 1 over 16 x squared plus 1. And as you can see here, our y is this one, our a is the 1 over 16, 8x minus h, so we have x minus 0, so our h is 0, so our v is 0, and then our h plus k, this one. So we have 0, 1. Our vertex, the vertex of this second parabola here is 0 at 0, 1. So once again, let me box this important element here. Okay, so right after that, what else do we need? We need to find the intersection points of these two parabola. Okay, so we need to find the intersection point. Intersection. So how can we find the intersection of these two parabola? Then we can solve this simultaneously. So we have x squared is equal to 16y minus 16, right? Then the other one is x squared is equal to 8y. Okay, so let's find the intersection by equating these two parabolas simultaneously. So if we have the x squared here is equal to 8y, so let's change this x squared with 8y. So we have 8y is also equal to 16y minus 16. Therefore, we have 16 is equal to 16y minus 8 minus 8y. Then we have 16 is equal to 16 minus 8y, we have 8y. Then to find the value of y, let's move let me move back once again this. So we have 0 is equal to 8y minus 16, so our y is just 8 is equal to y minus 2, right? So we have 8y minus 16, right? Therefore our y is just equal to 2. So if our y is equal to 2, then if y is equal to 2, so then our x squared is equal to 8 times 2, so we have 16. X squared is just equal to 16, and to get the value of our x, we need to find the square root of 16, which is equal to positive or negative 4. Okay. Therefore, we have this also important points or coordinates. Okay. So let me rewrite all of our important points. We have y is equal to 2. If y is equal to 2, then our x is equal to positive negative 4, as well as on our vertex 0, 0, and 0, 1. So for x squared, is equal to 8y, our vertex is 0, 0 at coordinate 0, 0, and for our x squared is equal to 16y minus 16, our vertex is at 0, 1, right? Okay, so now let's try to draw our parabolas. Okay, so we have the vertex of this parabola A. We have 0, 0, 0, 0. This is 0, 0. Then our next point is we have 2, positive and negative 4. See, this is 1, 2, 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, 3, 4. And see, we have this graph. We have 0, 0. We also have 2, 4, and 2. So our positive 4 is this one. Then our y is 2. We have this 4, positive 2, as well as on this side we have negative 4, 2. This point here, this is negative 4, 2. Okay, then this parabola A here is somewhat looks like this, right? Opens upward. It opens upward. Okay, this is a parabola. X squared is equal to 8y, and then our another parabola, we have the vertex is at 0, 1, so we have x is 0 and y is 1, so this is the 0, 1. Then point of intersection is also this point, so we have parabola that looks like this. And so we have a parabola that looks like this. This is x squared is equal to 16y minus 16. Okay, and our problem is to determine the area bounded by these two curves, so we need to find the area bounded by this curve. And so how can we find the area? We need to strip. Say, let me use another color. Say this is our strip with a length which is equal to y, wherein our y here is equal to the y is equal to the upper y h minus the lower curve minus the lower curve. Then we have the dx. Then we need the limits from, since we use dx, we need the limits from the lower limit x is equal to -4 up to x is equal to +4. Okay, so from -4 up to +4. Okay, we're gonna compute the area using the strips y strip or the vertical strip. Find this area from the -4 up to the +4. Okay, so let's try to substitute the value of the function of x in our y curve, higher curve. So we have -4 to 4, and our yh is equal to this part, the y of this part, wherein y is equal to x squared all over 16 plus 1, right? Where is that? This one. We have y is equal to 1 over 16 x squared plus 1. So we will substitute the value of our yh, function of x, is that we have x squared over 16 plus 1, and then minus our yl, wherein our y here is equal to x squared all over 8, so minus x squared all over 8, then dx. Okay, then we can now integrate this. Simply we have x cubed all over 16 times 3 is, we have 48, plus the 1 dx, integral of 1 dx, or dx is just x, minus the x squared, we have x cubed all over 3 times 8, so 3 times 8 we have 24. Then our limit is from -4 to 4, so we've applied the limit, so we have 4 cubed all over 48 plus 4 minus 4 cubed all over 24, then minus the lower limit, we have the -4 cubed all over 48 plus -4 minus -4 cubed all over 24. Then what we have here is equal to a is equal to 16 all over 3 square units.